Welcome to Learning with the Boys and Girls Club. This is part 3 of metals and nonmetals. If you haven't watched part 1 and 2, go back and watch that first and then come join us. This is testing your knowledge. Let's jump on in.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times,
magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, then argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gases stable, halogens and alkyl react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold,
thallium,
and lead, then bismuth for your tummy,
polonium,
astatine would not be yummy,
radon,
francium will last a little time,
radium,
then actinides at 89. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, and olevium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, meitnerium, dubsidium, rhenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and organesson, and then we're done.
Hey everybody, what do you need to learn today? You just need your thinking cap, pencil, paper. If you have a lap book or a notebook for taking notes, that's great too. Come on in and let's have some fun. Today we're going to understand that metal and nonmetal elements are on the periodic table and be able to classify them. Our unit learning outcomes are to describe how elements are classified as metal and nonmetal, describe patterns in data for metals, and explain chemical properties of metals and nonmetals. That's all just for the teachers. Come on in and let's have some fun. Our key unit words are periodic table, nonmetal, properties, solid, metal, metalloid, acid rain, and gas. In all of our previous videos, we've gone over what alkaline metals are, alkaline earth metals, transition metals, metalloids, halogens in either extensively or briefly, so you know where all of these metals are located. We may not have gone over exactly what the metals are, but by now you should know a little bit about how to find them. So I'm not going to go over that right now. If you need more information, go back and watch those videos. Metalloids. This is something new. Metalloids are elements that are considered to have the properties that are similar to both a metal and a nonmetal. Those are here. See the three? That is where metalloids start. Understand metal and non-metal elements are able to classify them. Did you know there are 5 metals that are a liquid at room temperature? Cesium, rubidium, gallium, francium, and mercury. Again, our keywords are periodic table, metal, non-metal, metalloid, properties, acid rain, solid, and gas. Our learning outcomes, we've already taken care of 2 of those, and now we're going to explain chemical properties of metals and nonmetals. Magnesium. Magnesium plus oxygen together is magnesium oxide. Metal oxides are solids at room temperature. They are alkali in nature. Sulfur. Sulfur plus oxygen is sulfur dioxide. Did you know that that's a formula just like you write in algebra? Non-metal oxides are gas at room temperature. They are acidic in nature. Non-metal oxides form when fossil fuels burn and the gases can mix with water in clouds, and that is acid rain. Burning fossil fuels release SO2 and nitrogen oxides. Sulfur dioxide, SO2, gas mixes with water to make acid rain, which damages trees and wildlife. So let's try not to burn fossil fuels. Key facts. Metals are hard, malleable, shiny, dense conductors. Non-metals are soft, brittle, dull, less dense, and don't conduct. Key facts. Metalloids are elements that have similar properties to metals and non-metals. Key facts. Metal oxides are solid at 20 degrees Celsius and are alkali. Non-metals are gases at 20 degrees Celsius and are acidic. They mix with water to form acid rain and damage the environment. Okay, it's your turn. Look at the data and state whether each substance is a metal, non-metal, or metalloid. You can go back and look. Remember, always go back and look. Pause the video and answer A, B, C, or D based on the melting point and room temperature, gas or solid. Okay? If you said that based on room temperature and melting point, correct. Melting point Celsius 115.2 was a gas. It's a non-metal. Very good. If you said 1460 degrees was a metal because it was a solid, correct. If you said a metalloid was 816 degrees Celsius and was a gas, you are correct. Same thing with metal. If you said a metal was 1210 degrees Celsius and was a solid, you are correct. Very, very good. All right, let's have a quick review. Magnetic metals are located on the left of the periodic table, and examples might be cobalt, nickel, iron, gold, and lead. Copper is not magnetic. Transition metals are good conductors of heat and electric currents. Examples might be titanium, silver, copper, iron, gold, mercury, and zinc. Aluminum and iron is a dense metal, often used to build items that float. The aluminum boat makes the density of the boat as a whole lot less than that of the water, so it floats. Shiny, hard, malleable, and high melting points are properties of metals that make metals the best substance to use for everyday uses, such as cutlery or knives. A substance evaporates and turns into a gas when it reaches a temperature above its boiling point. The boiling point of oxygen is negative 183 degrees Celsius. At negative 184 degrees, it turns into a liquid. A word equation for iron, Fe, reacting with oxygen would be iron plus oxygen is iron oxide. Okay. It's your turn. I want you to answer these questions. One at a time. Remember to pause your video and go back. Which is not a magnetic metal? Which of these is not a magnetic metal? Pause the video. If you said copper is not a magnetic metal, you are correct. Which type of substance is used for electronic wires? Metal. Metal is used for electronic wires. Osmium and indium are dense metals, whereas aluminum and iron are less dense. Which would I use to build boats with? If you said aluminum, you are correct. The less dense metals you would use because boats need to float, and it is better to use less dense elements. Also, more dense elements are more expensive. What properties of metals make metals the best substance for cutlery? Pause the video. Shiny, hard, malleable, high melting point properties are the best to use. Very good. What happens to a substance when it reaches a temperature above its boiling point? It evaporates and turns to a gas. Very good. The boiling point of oxygen is negative 183 degrees Celsius. What state is it at negative 184? If you said liquid, you are correct. And the last question, reactive metals are found as metal oxide compounds in the ground. Create a word equation for iron reacting with oxygen. You said iron plus oxygen is iron oxide. You are correct. I am very, very proud of you.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, and cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62. Samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. Hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead the bismuth for your tummy, polonium, astatine would not be yummy, radon, francium will last a little time, radium, then actinize at 89. This is the periodic table, noble gases stable, halogens and alkali react aggressively. Each period will see new outer shells will electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, indolium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, meitnerium, dubsidium, rucenium, copernicium, nihonium, flerovium, moscovium, livermorium, tennessine, and oganesson, and then we're done.
Look for other lessons, such as how heat changes the temperature of objects, cool periodic table, real life stuff, what silly putty was really for, and why it all really matters. See you soon.